Hello, we are in day 2 of Unit 5, Right Triangle Trigonometry, and the last lesson was a review of what you already know about finding the sides of right triangles if you have two sides. So today, this is what we're going to be working on, finding the sides of special right triangles known as 45, 45, 90-degree angles. So go ahead and open this up. Okay, so the first thing is I want to make sure that everybody completely understands the description of what we're learning about today. Please read this or make sure you translate it. You can copy it and you can go to Google Translate, but this is very important because again, what we're going to try to do is we should know that if you have two sides, of a right triangle, you can always find the third side using the Pythagorean theorem. Remember, the Pythagorean theorem allows us, if we have a right triangle, it's got to have a right angle of 90 degrees, right? But it allows us to use this formula here to find one of the missing side if we have two other sides. But we need to have two sides, okay? C is always the longest. It's always a hypotenuse, right, across from the 90-degree angle. Okay, and here's an example of how you use it. Remember, C is always a hypotenuse. Here's an example where we're trying to find the hypotenuse. Okay, and here's another example where we're trying to find one of the legs. Okay, but again, we have two sides, so we can use this equation to get the third side. Okay, but what we're going to do today is we're going to learn about a special right triangle. And again, the important part is that you understand this, that today, using right triangle trigonometry, and this is back in the description right here, if you only have one known side, but a non-90 degree angle as well that's given, you can find the third side. So again, make sure you understand and read this because that's what we're learning to do today, okay? First thing you should do is open these lesson documents right here to take some notes in Kami. So I'll open that up here. Okay, so I am going to take notes here, and then I want you to make sure you take notes in that document we just opened, okay? And you can also translate your document if you need to. Okay, so here's the first thing. If we have a triangle like this, let me go like this, that has a 45, let me go like this. If we have a triangle that goes like this, right? If we have, say, 3 and 4, and we're looking for x, we can always go 3 squared plus 4 squared. Don't take these notes. You don't need to, right? And then we can get x squared, and we can put this together, and we would get 25 equals x squared. We can do that. X equals 5, right? We can do that. But what happens if we don't have two sides? Then we have two unknowns, right? So what happens if we have a triangle like this? If we have, say, 5, for example, you did this in the warm-up, and it's a right triangle, but now you're missing two sides, right? So 5 squared plus b squared equals c squared. Well, the problem is we can't put these together, and we have two unknowns, so we cannot solve it. But what if I was to tell you that this angle here was the same as this angle here? Do you know what the degree would be of them? Well, remember, all three together would be equal to, let's just say, let's call this angle x, angle x. They'd be the same, right? Because they're congruent. And not only would they be the same, they'd both be 45 degrees or 90 together. Because if this is 90, we have a triangle equals 180 degrees for all three angles. 90 plus this, and they're equal. That means these two together equal 90, or 90 divided by 2 is 45. So it automatically makes these 45-degree angles, and this is what we call a 45-45 right triangle. And why does that help us with the sides? Well, because if it has the same angles, remember, sides correspond to angles. So if these angles are the same, remember, this corresponds to that, and this corresponds to that. So if the angles are the same, then the corresponding sides are the same, or the legs in this case. So that means that this is also 5, okay? So that's what we would know. And then now that we've got two sides, we can go 5 squared plus 5 squared equals c squared. And then this would be 25, this would be 50 equals c squared. And you know how to finish it, right? That would be whatever the square root of that is, would be that. I think it's about 7.1, maybe, something like that, close to that. But see, we can find it because now, again, we've got two sides. Even though we did not start by seeing two sides, if these are 45, 45, 90, it tells us that the sides that correspond to them are going to be equal, okay? So let's go to our notes and summarize this, okay? So we'll go ahead and use a different color pen. So again, if we know that this is 45 and 45, these are the legs, that means the legs are equal. So let's put that in our notes first, or the same. And the hypotenuse is equal to what? Well, it's going to be equal to the leg times square root of 2. It's always, that's the way it is when you have a 45, 45, 90. So it's going to be leg is 45, leg is 45, and then 90 is going to be leg times square root of 2. And if you go through, and you might ask yourself, why is that the case, right? Let's try that again. Let's go with 5. We already figured out it was 7.1, but what we're going to do now is we're going to go 5, and I want you to write these notes, 5 squared plus 5 squared equals c squared. On your calculator, these are both 25, so this would be 50 equals c squared, okay? And if 50 is equal to c squared, we take the square root, and then we get square root of 50 equals c squared, okay? Now, part of it is we have to simplify, okay? So that means we'd have to say that this is the same as 25 times 2 equals c. And by the way, this is c, not c squared. Well, what is the square root of 25? Well, that is 5 times root 2 equals to c. So you have to know that you can simplify this down to 5, okay? So that's what that means. Now, what is a leg equal to? Well, the leg is going to be equal to, remember, the hypotenuse, I should make that a h. It's going to be the hypotenuse divided by the leg, divided by the root of 2. It's the opposite of here. If the leg times root 2 equals a hypotenuse, then the hypotenuse divided by root 2 is equal to the leg. Okay, let's see how that works out over here, okay? We're going to solve for the missing sides in each triangle. If you have an idea how to do it, you can try it and pause the video. Otherwise, you can go to this. You can say, okay, this is 45, so that makes this 45. So that means this side here is the same as this side. Well, this side's 9, so this side's 9, okay? Now, we could go 9 squared plus 9 squared, and we could keep going, dot, dot, dot. But if we know that this is a 45, 45, 90, we know that the legs, these are the legs, hypotenuse is equal to the leg times root 2. Well, this is the leg, right? So that means 9 times root 2 is equal to that. And we're done. It's that quick. So it saves us a lot of time, okay? Now, here's another one. So you may want to try this if you've got an idea. But here, these are telling us that these two are the same angle. So they're congruent. Well, if they're congruent, we've got a 90. That makes them 45. So that's one thing to be looking for, okay? So what do we have? Here we have the hypotenuse. So now we're going to use this, and we're going to go hypotenuse divided by root 2. So 11 root 2 divided by root 2. Well, this and this are the same, so they cancel out, and we get 11. Okay, so the leg equals 11. And we're done, and it's that fast, okay? And if you want to try it, you can do that. 11 squared plus 11 squared would equal 11 times root 2. Okay, so for now, I think that's okay. Oh, I'm going to do one more. Let's look at, don't worry about this one. What if we have this one? Here, the legs look like the hypotenuse, but it's not. Remember, the 45 are the legs always, and this is the hypotenuse. So we know that this is automatically 6 root 2. So what's hypotenuse? Well, again, we're going to use this over here, right? So leg, 6 root 2, and again, times root 2. Okay, well, here's the thing to know about it. If you have, and this is important, if you have root x times root x, that is equal to x. Let me give you an example. What is the root of 4? It's 2, right? Well, What's root 4 times root 4? What's 2 times 2 is equal to 4, or 4, right? So that's the principle right here. So that means that, and here's another thing to write down. If you have root x times root y, that's equal to xy root. Example, 2 root times 5 root equals the root of 10, and vice versa. You can break it down. You can say that's the same as root 5 times root 2, okay? All right, so now here we know that, so this is going to be just 2, 6 times 2, and that's equal to 12, okay? So this would be 12, okay? So those are the principles that you're going to use today. Now I'm going to go to the assignment and do the first 2 questions with you, and then let you do the rest. Okay, so go ahead and open the assignment in Kami. Okay, so we're going to again find the missing sides of the triangle. And one of the things that you'll notice is it says leave your answers in radicals. Radicals are like this, root 2, because if we took our calculator and did that root 2, it would be 1.41 approximately, right? But we're going to leave it like that instead of using our calculator. It's much quicker anyway. All right, let's look at number 1. Okay, so right off the bat, you should notice that this is 45. So what is this? This is going to be 45 too. That means the legs are equal. What are the legs? The legs are 6 and n. So that means n is going to be equal to 6. Well, what's m? Remember, we know that the leg times root 2 is equal to the hypotenuse. So I'm just going to use that hypotenuse leg. So that means we have 6 root 2 is equal to the hypotenuse, which is, in this case, that's the m, right? So that's m over here. Okay, what is that? That's going to be, let's see, m is 6 root 2, and n is, okay, so that's going to be c. Okay, if you want, you can try 2 and pause the video and come back and see if you've got it. Okay, so now that we've come back, what do we have? Again, another 45, 45. That means the legs are both going to be equal, so that means this would also be root 2. Well, what is the hypotenuse? Well, it's going to be the leg times root 2. Well, our leg is root 2 times root 2. Remember, if you have the same thing, that's just going to be equal to 2. Easy enough, right? So m is 2, and the other leg is root 2. Okay, let's see if there's anything else that's really weird. This should be about the same. That should be about the same. So I don't think there's anything too weird. Oh, let's look at, try number 6. If you want to try number 6, because it's a little bit different, you may want to pause the video, but I'll go over that one for you, okay? Okay, so again, it's the leg, so that makes y also 2 root 3. And remember, leg times root 2 equals hypotenuse, right? Lost my pen. So that means we've got 2 times root 3 times root 2. Well, remember what I said earlier, these two are the same as 2 times root 6. Okay, so that's going to be your x. X, and then the y was 2 root 3. Okay, so there you go. So now you can complete the whole assignment and just let me know if you have any questions, okay?